topic of this session, which will be delivered by Mr. Dipankar Sen. The topic of his talk is Optics and Photonics, Weapon to Untangle the Mysteries of the Universe. This is one of the most awaited talks of this session, and he is joining us from Texas, USA. So I think it must be early morning there. So good morning to you. Welcome to the session. Can you hear me?
Yeah, I can hear you. Can you hear me?
Yes, sir. You are perfectly audible.
Okay. Thank you for such a nice introduction. Yeah, it's an early morning, and yeah, in India it's kind of evening. So good evening to you. And also, I want to thank Masterclass for inviting me and amending the schedule because of my time zone. So, shall I proceed? Or
Yes, we are good to go. The screen is
okay,
yours.
thank you. Okay, so can you see my screen? Could you please confirm?
Yeah, it's perfect.
Okay. So, yeah. So at first, let me thank all of the masterclass people for inviting me, and especially Kuntal and Devasrita to as they contacted me and arranged this meeting. So let me start my topic. So my topic of the talk is optics and photonics, weapon to untangle the mysteries of the universe. So actually, we think that this is a part of physics, and unfortunately, it is not getting that much attention in India. So that's why I just try to I'm trying to inform you that how actually this field is connected to every field of physics. A huge amount of chemistry is also connected here, as well as other biomedical applications, engineering applications, and all. So I am currently a PhD student in Texas A&M University, and as well as I am a teaching assistant. So I basically take classes of undergrad. So this is, let me just, okay. So can I just, this one? So let me just change my pointer. Okay. So this one is my department. And the large picture is actually our university. So you can see that this is a huge university. So we have like clicked a drone view, and my department is situated exactly at this location. So yeah, we can move forward after giving this formal description of my current status of PhD student and a teaching assistant. So this is the picture. So you can see clearly that there is optics and photonics and center, and we have different disciplines: physics, electrical engineering, chemistry, material science, biomedical applications, photonics engineering. So it means that you can join or you can work in optics and photonics field if you belong to any of these disciplines. So it doesn't matter whether you are coming from only physics. I have appeared in this field from physics discipline, so I will mostly talk about that, but please keep in your mind that you can join or you can work in optics and photonics field from any of the disciplines. Okay. And the main question is, why did I opt for optics and photonics? So I personally belong to West Bengal, and there is like lots of craze for theoretical physics and astronomy and other stuff. So that's why I actually thought that yeah, I won't do that because like there are too many theoretical physicists and etc. So I am all time like I don't want to follow all the people who, like what they are doing. So that's one major reason for opting this optics and photonics field. And also sometimes I think like okay, it's fine. So there are so many things that are happening in outer space, cosmos, and etc. Everything is cool, but that don't have exactly direct application in our real life. The normal people, common mass, don't get benefited from those kind of stuff. So that's a huge project. That's fine. So that's kind of mesmerizing. So we are going to like moon. We are discovering black hole. It's fine, but there is not any direct application in human life. So that's the another reason for choosing me. And yeah, also as a child or like during my adolescence or teenage, whatever you can say, I usually get attracted by lasers and LEDs. And but still, that time I didn't know from of this field. So this particular invention, this Nobel Prize in 2014, that came for blue LED. That actually kind of let me decide to join this particular field. So let me just go through a little bit from the history to the current time. And as most of the participants maybe do belong to 9 to 12 background, so that's why I thought that let me just go through history, that how the history of optics and photonics evolved. And also the Nobel Prize is something which attracts like young mind, right? So that's why I thought to talk about this particular thing. So the first ever Nobel Prize which came in the field of optics and photonics is for Michelson's interferometer. So if you know about Michelson interferometer, I think some people of you guys know that the result of this Michelson interferometer. So this is one of the experiments which actually led Einstein to propose this special theory of relativity. There is a concept of ether and etc. So I won't go much detail. And another thing which is pretty much interesting is that you know that in 2016 the gravitational wave was detected, right? So actually this Michelson interferometer was used for the detection. So you can see that optics and photonics is not about only optics and photonics. It has connection with other stuffs also, like interstellar, like the stuff which comes from space and outer world and something like this. And the second one is was awarded to Dr. C.V. Raman or Sir C.V. Raman. So he is only one Indian physicist who got Nobel Prize. Yeah, there is another one American physicist who got Nobel, that's Chandrasekhar for his Chandrasekhar limit, but I don't want to say because he was American then. So C.V. Raman was the only one Indian who was awarded with Nobel Prize for something which is known as Raman Effect. This Raman Effect can use in material identification, the imaging of small molecules like nucleic acid. So it has a huge application in biomedical field also. So let me just move forward. The next one was awarded to Frederick Zernick in 1953 for his demonstration of phase contrast method. So earlier what happened that we were unable to see the structure of cells and etc. by using bright light microscope. So he actually proposed a method where we can see the cell structure and other thing without using a dye. So whenever we use a dye, there's a huge probability that the cell might die or something. So by his method, we can see actually the cellular structure of live cell. So it's not going to be dead or something. So this has a huge impact in the field of biomedical applications. And the next one is one of the greatest discoveries in the field of optics and photonics, which was awarded to Willis Lamb for the fine structure of hydrogen spectrum. So Willis Lamb is not about only the fine structure of hydrogen spectrum. He had done, actually his group has done a huge amount of work in the field of optics and photonics, mostly. Even the first laser which was prepared by Myman, so Myman was his PhD student. And even if we go to quantum optics, quantum theory of laser, that was actually done by Willis Lamb and another guy known as Merlin Scully. So Merlin Scully was also a big guy. So he was his PhD student. He was PhD student of Lamb. And he actually, the Merlin Scully, I'm talking about Merlin Scully. So he actually won everything till date except Nobel Prize. The highest award of the optics and photonics field, which is Eves Medal, he won. And fortunately, like he is the director of the IQSC. So, and he's also a co-PI of mine. So that's a nice experience actually. If I just move forward, the next one was awarded to Prokhorov and Towns in 1964 for the theory, the first theory of laser or something known as masers. So laser is like light amplification by stimulated emission of radiation, and maser is microwave amplification by stimulated emission of radiation. Okay, so this maser was used in the field of astronomy in a huge proportion. Even it helped to discover different complex molecules and space, and also it was used to measure the mass of a supermassive black hole at the center of Milky Way. So these are everything comes from optics and photonics. So you can understand that it has huge application in astronomy and space sciences as well. So let me just move forward. So the next one was awarded to Denis Gabor in 1971 for his invention and development of holographic method. So you know about different shows of holograph, which is like quite like available nowadays. It can be used as used for data storage, image processing, optical computing as well. So this was a very good discovery, which actually had a great impact of human life. So if I just now move forward to the next two Nobel laureates, which is Qualo and Blombergen. So you can see that they contributed a huge in the development of laser spectroscopy. So spectroscopy is a tool which can characterize material, and that can be used in image processing and all. But why their discovery is so much of important? Because earlier we had everything like we are using the spectroscopy by using only the visible light, the VGR, from 400 nanometer to 900 nanometer. But there are so many materials or something which we can see only if we go to the ultraviolet range or infrared or something like that. So actually they helped by using the nonlinear optical effect like second harmonic generation, different frequency generation or something like that. So say suppose I have used 500 nanometer light and we are using say second harmonic generation. So that will lead to a frequency of light of 250 nanometer, which goes in the range of UV. So you can see that if I can produce that light, we can see the object which are not visible in visible ray, but they are visible in ultraviolet ray. So something like that. So they have used these nonlinear optical tools to improve the spectroscopy techniques, and now for them we can see the stuff by using infrared and ultraviolet rays. So let me just move forward. This was one of the greatest discovery, as you can say, so by Stephen Chu, Cohen Tanuji, and William Phillips. So they actually developed a method to cool and trap atoms with light. So there is something, if you know, or maybe I don't know, I think few of you have heard about something known as laser cooling. So by using this technique, we can go to very low temperature, near absolute zero. And in that temperature, we see that the physics of materials change drastically. And this time, if we go to this temperature, we can achieve superconductivity in many materials. So that is also kind of helpful in the field of material sciences, as well as it is helping for solving the problem of superconductivity, because the main motivation to get a superconductivity, so if we can get superconductivity only if we go to the very low temperature, and this temperature is known as like critical temperature or something, and this is very low for many of the materials. And we are now trying to find some materials which can show superconductivity in room temperature. So if we get that kind of material, we don't need to do this kind of cooling and etc. stuff, because this is like kind of costly. So let me see if we can get something in future. So the next one was awarded to Cornell, Ketterle, and Women. And what they have done, They actually use the laser cooling technique and the normal evaporation cooling, right? So whenever we like make a tea or something, coffee, we keep it for some time so that the temperature gets reduced. So they use that technology as well as a laser cooling developed by Cohen-Tanucci et al. And that actually led to the Bose-Einstein condensation in dilute gases or something like that. So if you know the Bose-Einstein condensation, so it's something like you heard about Bose and Einstein. So they have proposed a theory known as the Bose-Einstein theory, and that is followed by almost half of the particles in this earth, and that they are known as boson. I think you have heard about the Higgs boson, for which Higgs got the Nobel Prize. So they use this laser cooling technique and evaporation cooling technique. They couple those two techniques to get the Bose-Einstein condensation. So the molecules or atoms of bosons, they actually reach the ground state at low temperatures. So for this technique, they was awarded with the Nobel Prize. Yeah. After that, the Nobel was awarded in 2005. Half of the contribution, like half of the Nobel Prize went to Glover, and the rest half was like shared by Hans and Hall. So there was a huge controversy regarding the prize of Glover, and many of us believe that there was one Indian who was denied a Nobel Prize. So he was like ECG Sudarshan, if you have heard. So he was then the professor in UT Austin, the university beside my university. So many people think that he should have awarded with the Nobel Prize because he actually proposed the theory, and Glover Glover helped in the advancement of the theory. So it's something like actually Sudarshan told that if there's a building and some builder has built the second floor, but you are only giving the credit to the person who has built the second floor, but you didn't give the credit to the person who actually laid the foundation of that building. So there was a huge controversy. So he actually proposed, like actually Glover and also ECG Sudarshan was proposing the Optical Tweezers, which is very much useful in the advancement of laser. So that's why he was awarded with the Nobel Prize. And another half of the prize got to Hans and Hall. So they have actually developed something known as frequency comb. So earlier we had talked about second harmonic generation, different frequency generation and all. But what is frequency comb? So what comes to your mind as a comb, right? So there are like something, so which is like equally spaced and you are using that to comb your hair. So this is also something like that. So if you have only one frequency, you can create equally spaced lots of frequency on the either side. So that's why it is known as the frequency comb. So we can actually prepare an entire spectrum of light or something by using this technique. So this is a great discovery in the fields of optics and photonics. And this actually is our workload. So because just one technique can produce the huge amount of, like huge number of wavelengths. So if we just move forward, it is like after 4 years, Cow was awarded with the Nobel Prize with Boyle and Smith. So Charles Cow actually like kind of worked on the advancement of optic fiber. So now by using optic fiber technology, you know that data can be transferred from one place to another place. And if we use the optical fiber properly, this data transfer can happen up to 10 Gbps speed. So you can understand the huge speed of data. And I think in India also nowadays government is also initiated some kind of project or something by using this optical fiber technology to transfer the data and all. So it's kind of digital India. And the other half was shared by Boyle and Smith. So they have invented something known as CCD tensor. So it's like charged coupled device or something like that. And this has huge application in detection of light. And this kind of things are usually used in Hubble Space Telescope or different kind of telescopes which our astronomy and space science colleagues have. So the application of optics and photonics is also important in the field of astrophysics. If we move forward, the next one was awarded to Weinlein and Haroch in 2012. So they have actually developed something known as quantum reads, quantum logic gates or something, and can be used to save the data and etc. So you know about logic gates, right? AND gate, OR gate, NOR gate, or something like that. So this is quantum logic gates. So the quantum version of logic gates or something. If we just now move forward, this is exactly the Nobel Prize which led me dig into the field of optics and photonics, which is blue LED. So it was awarded to Akasaki, Amano, and Nakamura is holding a blue LED. So what happened, you know that there are three major color, right? Red, green, and blue. If you have these three colors with you, you can prepare every kind of color. But earlier, what was happening, they have only red and green LED, but they didn't have a blue LED. So people were unable to create a white LED. So now you can see that there is white LED everywhere, but it was not possible then. So these three people actually discovered the blue LED. Even many major companies, many industries tried, but they failed. But these three people actually made this blue LED. So this was a huge application in everyday's life. So now we are using a less waste of energy and it's environmental friendly. So now the environment is changing and etc. So this has a huge impact, So this was the last Nobel Prize which is awarded till in the field of optics and photonics. So half was gone to Arthur Ashkin for the discovery of optical tweezers. So optical tweezers is something like that. We can trap very small microscopic object like say cells, DNA, RNA or something, and we can manipulate. So it actually helps in something known as gene engineering. So we can actually prevent many kind of diseases or something if we can manipulate the genetic materials of the viruses and all. So this is something which is known as optical tweezers, and it has a huge application in the field of biomedics. And the other half of the prize was awarded to Gerard Mourou and Donna Strickland. So Gerard Mourou was the PhD supervisor of Donna Strickland, and they got awarded with the Nobel Prize for something which is known as chirped pulse amplification. So they have actually developed this technique, and this was helped to get an ultra short pulse. So the pulsed lasers, which has a duration in the femtosecond, so 10 to the power minus femtosecond, to attosecond, which is 10 to the power minus 18 second. So if we can get light pulse of that much short time duration, we can probe different chemical processes. We can see what is happening in the molecular level, how the chemical reaction works. So this has a huge implication, and now chirp pulse amplification is used widely. So we also use, everyone, I think the people who are in the field of laser or optics photonics, they use. And the nice thing is that this was discovered by Donna Strickland during her PhD time. So when I think she was 23 or 24 years. And another thing is that this was not published in very high reputed journal like Nature or Science or something. It was published in some small journal known as Optics Communication, which has near about only 2 impact factors. So you can understand there is they thought this is a small discovery, and then it came out as big. So that's how we reach the current time in optics and photonics. So now, we have already talked about too much about history. Now our life is heavily impacted by the SARS-CoV-2 or COVID-19, right? And here also optics and photonics now playing a huge role to fight against this, because we know that there's no vaccine. So the best way to slow the spread is the early detection and the sterilization of contaminated surfaces, because there can be indirect transmissions. So this is a picture of thermal image. So we know that the human body, so human body has some temperature, and then temperature is connected to some kind of wavelength, because kBT is like AC upon lambda or something like that, if you know. So our body actually emits the wavelength of 9 micrometers. So if we see, or if we detect the change in that wavelength, so there might be the change in body temperature. So if we see that there is some kind of increase of body temperature in someone, so there is a possibility of SARS-CoV-2 cases. And this kind of thermal imaging is used in international airports and etc., where we can't just measure the temperature individually of a particular person. So we go through some kind of window or something, and they scan us to get the body temperature or the wavelength, whatever you can see. So these are the what kind of materials which can use to detect. So there are like semiconductor diodes are there. So we can use this kind of materials to use this thermal sensing technology. So now if we move forward, you have heard a lot of about Rtpcr, right? But what is this Rtpcr? So Rt stands for reverse transcription, and PCR stands for polymerase chain reaction. So what is transcription and reverse transcription? So you know that SARS-CoV-2 is a virus which has RNA as genetic material, but we can't amplify RNA as we can't amplify RNA as easily as DNA, and that's why we are facing too much difficulty in discovering the drug or vaccine of COVID-19. So we use reverse transcription process to make DNA from RNA, and we amplify the DNA by using many processes. So that DNA is connected with some kind of fluorescent dyes or quencher, and we use a particular wavelength. So after each round, the DNA amount is getting amplified. So the more amount of DNA is possible, there's a high possibility that we get a better result, right? So this is how we actually use this Rtpcr. So polymerase chain reaction means like within the by using the chain reaction, it is getting polymerized, so it is getting amplified or something like that. So I am not going into that much details that how does it work. So this is the kind of brief introduction of this Rtpcr, and there is an image of a scientist who is actually like using this Rtpcr to detect something. So if I now go forward, so now that's the Rtpcr. There is something which is known as real-time Rtpcr, and this technique is used. So here we use optical technology to detect this COVID-19. So what actually happens, we have a light source. So this means like red, blue, yellow. So that means like a broadband light. So there is an excitation filter which actually allows to pass a particular wavelength. And this wavelength is getting reflected by this dichroic filter. And by using a small microscope, we focus that light source on the slide where the sample of a possible SARS-CoV-2 suspect is there. And there is some kind of things are happening. And the light which get deflected from this sample, that again passed through this emission filter, and it was detected by this camera. So here we actually measure that what's the amount of fluorescence, or that what kind of light is coming from this sample. And from that we can say whether a person is a SARS-CoV-2 positive or not. So this is a pretty much nice thing, and this is widely used nowadays. So you can see that it's not about only optics, photonics, it's not about only astrophysics or something. Even at this current time, the optics is helping us to detect the SARS-CoV-2 cases. And the another thing which I should mention, that's a serialization of surface. So there's a like huge increase of cases, not because of direct transmission. It is also coming due to indirect transmission. So there is some SARS-CoV-2 positive person is there, and he or she has sneezed or something, and from that it has like contaminated some kind of surface. And if we touch, and by like unknowingly we can infect ourselves. So nowadays they are sterilizing the surface by using ultraviolet laser. So this ultraviolet C, so C is the region of the huge ultraviolet spectrum that works in like 200 to 280 nanometer. And this actually mutates the RNA of SARS-CoV-2. And if we can like mutate the genetic material, then it actually stops the virus replication. So even if some small amount of virus is present on the surface, that can't replicate. So we have just changed the genetic material. So even if it gets entered in our body, it doesn't replicate. So we won't get affected by SARS-CoV-2. So this is nowadays used by different companies or something to sterilize the surface or whenever they are delivering the stuffs. And this is our work. So we are actually working on the detection of antibody by using MZI, which is Michaelson Interferometer, or a multi-channel young optical sensor. So what happens? So this is a 4-channel YI. So this will be YI, young interferometer. So there are like 4-channel young interferometer sensor device. So this W1, W2, W3, W4, these are sensing windows. So at particular sensing window, there will be a reference material, say the antibody of the SARS-CoV-2, and here also it will be there. And now you know that antibody antigen binding. So antigen is specific to some antibody. And we have collected the sample from different people, and we put the sample in this sensing windows. So if the person is SARS-CoV positive, so when antibody is connected with the antigen, it actually changes the phase. It actually changes the wavelength. So from this laser, one wavelength is coming, right? And it is going in different channel. So if it's a SARS positive case, then in the sensing window, the material will be different than the antibody. So there will be change in like phase, and we will see that interferometer pattern in this screen will also change. So from that we can understand whether the person is SARS-CoV-2 positive or not. So we are, and this is a very small region. It takes a very small region. So actually we are trying to use this technique to detect the SARS-CoV-2 cases, and it's under preparation. Let's see whether we can enhance the sensing or not. So that's why we have chosen this project, and I also want to credit Oral MET from University of Twente for the figure. I am using this figure directly from his thesis. So this is what we are doing. So in our university, we are not only doing this, we are using different kind of techniques, and we have also prepared a testing kit, and they have already like awaiting for the acceptance of the patent. So we have filed the patent application for the testing kit. So that's the main kind of topic of my talk. Now just let me go through that what actually I did before appearing in this field of optics and photonics, because there are like I think participants from 9 to 12 background and BSc. So I did the BSc honors in physics from Hooghly Mohsin College, the same institute from where Kuntal did. So yeah, he was my junior. So after that, I had like cleared JAM and GIST. So they're like, you can go in IITs, IISERs, IISCs from these examinations. And I have also cleared the BHU and JNU. So I had two options, but I chose the IISER. I didn't choose BHU. If I had chosen the BHU, then maybe I could have like meet you guys in person. So after GIST, I gave the interviews in different institutes, and I got selected in the integrated PhD program of IISER Bhopal and something known as IACS, which is Indian Association for the Cultivation of Science, where actually the Raman discovered his Raman effect with the help of K.S. Krishnan, who was a PhD student under him. But I joined IISER Bhopal because cultivation was like, I was in waiting list then, and the registration of IISER Bhopal was on the same date as the, what do you say, counseling. So actually, like I would have selected in IISER also the way they actually went down. But yeah, I joined IISER Bhopal, and actually that helped me because in IISER Bhopal, I found like too many people of optics, like not direct optics, I can say, at least spectroscopic techniques. So I worked in something known as transient absorption spectroscopy, and I did my master's thesis on that. So this was something like CSPBR 3MOS2 heterostructure and probing the exciton dynamics in that. So after that, so this is an integrated PhD program. So this is MS and PhD all together. But after, like during my masters, actually, like my then girlfriend, my wife, so she actually like influenced me to apply in ESA, and I got the acceptance from Texas A&M University and Florida State. So Texas A&M is very good in optics. So if you want to pursue this optics and photonics field, you can consider Texas A&M. We have Nobel laureates, the highest like optics medal awardees, and etc. So you can think about it. And Florida State University is particularly very good in something known as magnetism. So if you are interested in magnetism, I will urge to apply in Florida State because we have like National Magnetic Lab of USA in there. And yeah, if you are also, if you want to apply in astronomy and cyclotron, so in nuclear physics, you can also think about Texas A&M University because like nuclear physics of our university stands in top 5 in throughout the world. So you can think about that. And after that, there was an option of MS exit. So I took an MS exit and I came here in Texas A&M. So this is my journey. Now, what you can do. So I have focused on the students who are going to appear in 12 in future, like 10+2. And maybe I think some undergrad students are also there. So what they can do after BSc. So if you are now studying in school, so there are like so many options. You can clear KVPY, Kishore Vaigyanik Protsahan Yojana, and you can secure your seat in IISERs for BSMS, or maybe you can join in IISc Bangalore for BS. So that's a Bachelor of Science. So yeah, I earlier didn't know about this kind of stuff. So I didn't know that there is something known as IISER at that time, something known as KVPY. So I didn't appear in the exam. But now you guys know about something which is there, so you can try. And also you can take JEE Advanced. So if you get the rank within 8,000 or something, you can apply in IISc Bangalore or integrate MSc in few IITs. So to my knowledge that there is an integrated MSc option, which is also like same as BSMS in IIT Kanpur at least. So you can think about that. Earlier IISER used to take from JEE Advanced, but I think from this year there is no JEE Advanced channel or something that, or maybe they have reduced the seats. And another thing is that something known as IAT, which is IISER Aptitude Test. So if you clear that, you can get seat. So yeah, secure seats. So there will be seats. Those small spelling mistake. So there are like 7 IISERs right now. So you can get into any of these, and if you are like kind of confident, or if you think this research is going to be your profession, you can surely think about IISER because like the environment is something like that. It will be redirected to the research because of your peers. And so you can join also the state universities like JU Presidency, St. Xavier's, or colleges in under the CU, BU, or different universities. So here I have given the example of the universities in West Bengal because I do belong to them, belong to that state. But yeah, there are like lots of universities in different states. So you can choose any of those. So that's what you can do after 10+2. So for the first year option, it's mostly like your till master, your life is secured. So you don't need to think about till master. But for the fourth option, you have got only BSc. So what you can do after BSc? You can clear something known as JAM if you belong to physics background, as well as chemistry and biology. Okay. So now you can secure a seat in IITs or NITs to do MSc, only MSc, not integrated PhD. And you can clear JEST and interviews or entrance exams of IIScs, IISERs, TIFR, and another research universities or institution to join IPhD. And the thing is that this jest is for only physics and maybe I think computer science people also. But if you want to join in this institute, there is only one option, or maybe like few options is also possible in bio background. So I am not pretty much sure of that. So in case of chemistry and biology, there is an option to join these institutes by clearing JAM. At least IISc and IISER, TIFR takes as own exam in other field. And also, like if you think that you don't want to join an integrated PhD, which actually directs you to research, and you are not sure about that, so you can clear the entrance exams in different central universities like BHU, JNU, Delhi University, Hyderabad Central University, etc. And you can also go to different state universities. And after that, you can think whether you want to pursue the research or you want to pursue some job or something like that. So this is what you can do. And I will like briefly talk about the PhD application procedures both in India and abroad. So in India, if you have completed your MSc and if you want to pursue a research career, you can qualify something known as IISER UGC-NET. I think few of you know that, or say GATE or CHEST. So you can clear maybe 3 or maybe one of 3. It doesn't matter. So if you can clear 3, that's very good. But if you can clear only 1, that's also not going to impact. So after that, you really have to shortlist university or institutes according to your research interest. Means that so you have got attracted towards some particular topic. So I will urge that don't go for the name like IISc, TIFR, IISER or something like that. Go to the institution, find out the faculties if they are working on your field. So if you have say got into IISc and you didn't able to find a particular professor who is working on your field, you will get frustrated or something. I have seen many of the people who left PhD or something. So that's major thing. You have to select the universities or institute according to your research interest. And then crack interview. There will be interviews or maybe some written test. And if you clear, you have got into that institute. Yeah. So now I will actually try to, I have actually tried to focus on the PhD application procedure in abroad, especially in USA. So that's why, what do you need to do at first? You have to take GRE. And I have also like written the prices. So this $190 is for general GRE, which constitutes of English and math only. And there is $150 for subject GRE. So if you belong to physics, chemistry, biology or something, you need to take a subject GRE. And there is something which is known as TOEFL. So this is English language proficiency exam. So you need to score a certain mark. So it's like 120 is the total marks. You need to score at least above 85 or 90 to begin apply in different institutes. And please remember, these are not entrance exam. So I think like one previous speaker told that it's entrance exam, but I think she is not pursuing PhD in US. So these are not entrance exam. It doesn't matter. Maybe you have scored in GRE or TOEFL, say 10 or 15 marks more than that, but there's a huge possibility you won't get accepted, but I will get the acceptance. So another thing is obviously select universities. So if you are say now in master first year or now you have like completed master's first year, so you should start selecting the universities according to your research interest. So don't follow the ranking. There are like bad faculties or bad researchers in even in Harvard or Princeton. So don't follow the ranking. Just think about the research area where you are going to work. Is that good in that particular university? Is faculties are good there? So our faculties are good there. If good, then go for it. But here also you need to think about what did you score in your GRE and TOEFL. So some universities or some institute has some kind of like minimum points, but obviously that minimum points is not that much like kind of trivial. So say you have scored, so suppose say my university has like cutoff that you need to score in TOEFL more than 95. Say you have scored 90 to 93, but Your other scores, the GRE is better, your research aptitude is very good, you have done very good internship, you can still apply because they will consider not only one thing, they will consider you as a whole. So this is GRE to FL, and the next step is very much important. That's the application. So you have to prepare a CV or a resume. You have to write statement of purpose or research statement for different institutes where you are applying. And you need to get 3 letters of recommendation at least. So this letter of recommendation will be given by the professor under whom you are working as MS project, or under whom you have done some internships or something. And if you have done some internship in different companies, so you can get the letter of recommendation from your boss or something like that. So after that, they apply in different institute. And here also during the application, like all of the universities or institutions throughout the USA has some amount of fee, and that's not same in different universities. So you need to apply, you will get acceptance. After acceptance, it's not the only one step. So there comes a vital step, getting the visa. If you have got the acceptance but you didn't get the visa, you are not going to come in US. So you need to pay something known as service fee. So say you have got the acceptance of like 3-4 universities, or say 10 universities. So they will send you offer letter, and you have to send it back to them. So you need to sign it whether you are accepting the offer or you are rejecting it, and you need to send it by usually 15th April. So that's usually the date. So you have selected a particular university where you want to join, and you have sent the application back to that university. They will send you something known as I-20, and you need to pay the service fee for that particular university or institute. And after that, you need to apply for visa. There will be something known as DS-160. So you need to pay $160. After that, there will be visa interview. If your visa interview got perfectly well, they will give you the visa within few days. And sometimes it happens in many fields like nuclear and etc. So they usually give something known as 221G. So that takes 4-5 week times, because nuclear science is something like people can use the confidential information and send to other countries, and that might be harmful for US. So that's why they take some kind of time to screen your background. And after getting everything, your visa is ready in hand, then take flight, book flight, join your dream university. So if I just like say convert into INR right now, so maybe in entire application processes and flight and etc., the cost would be like around 2 lakhs, less than more than that, depending on how many universities you are applying. So that's the entire like PhD application procedure in US. So that's the thing I wanted to focus a lot. So now it's okay, you have joined PhD, you have got the doctorate degree, but what's after that? After that, you need to get some kind of job or something to sustain yourself, right? So it's not like that you have to stay in academia and have to become a professor. There are like some non-academic career in optics and photonics also. So one is like traditional academic career, you go for postdoc and become a professor or research scientist in different universities or institutes. But for optics and photonics, the non-academic field is huge, and it will give you actually like it will pay you more money. So you can become optical engineer and research scientist in different companies. So why particularly that optical engineering I have written? So it doesn't matter if you have a BTech degree or not. If you just came from like physics background and got a PhD and your work is very good in say building instruments or say building the sensors, you will get the post of optical engineer. And I'm pretty much sure about that. Like few of my senior lab mates here actually joined industry as an optical engineer. So you can go for that also. And there is a huge demand of laser scientists in different defense organizations. So nowadays, laser is also like kind of laser and different kind of wavelength based weapons are used in defense organization. So there is a huge demand in defense organizations, including our BARC and DRDO in India. And another option is like you can become a scientist in medical research institutes. So I have told you about the SARS-CoV-2 cases and different kind of application, different kind of invention in optics field, which actually led to the advancement of medical field. So you can become scientists there also. And there are many more job available in non-academia too, if you pursue this optics and photonics field. So that's it. So that's what I just wanted to say from the history of optics and photonics and how the optics and photonics is working in the current scenario of COVID-19, and how can you get into this field and what can you do after getting a PhD or something. So that's just I wanted to say, and thank you all for the attention, and thank you for inviting me to present a talk. Yeah, that's it.
Thanks a lot, sir. It was beautiful to retrace the history of research, path-breaking researches in optics, to revisit the Nobel Prize awardees. The list was quite long, as I can see. We should realize how important is the field of light and matter as a field of research, that it has managed to secure a number of Nobel Prizes in physics. And thanks for also highlighting the significant part on the research on SARS-CoV virus. This is quite significant in the perspective of present time. And thanks for pointing out the point that exams like GRE and TOEFL are only the necessary condition, but not the sufficient condition to secure a place in abroad. So we have a question in the chat box, which asks, so what are the basic difference in doing research in specifically, between India and abroad or USA?
Okay, so it's like that. If you focus in the research stuff in India, it is mostly theory based, at least in physics. Somehow I don't know, our government or different organization don't want to do something in applied field, even if we are like talking about the Atmanirbhar Bharat, but still the funding is a huge issue. So like students are mostly, or faculties or people are mostly like interested in some theoretical field, some aspects of astronomy, space science, and etc. So people, or say the government or different funding organization, don't give that much funding in applied field, even if it's required. But if you want to like pursue the fields in applied, so either maybe you can go to BARC or DRDO. So that's in early time, and to work in different kind of projects. But if you want to like do something on your own, it's very unlikely that you will get huge amount of scope in India, because like there are only few institutions like IISER Bhopal. There are like so many people on spectroscopy and like in some applications of optics and photonics, but it's not like the same in other institutions. So that's another thing, that there is very less funding, there is very less opportunity to pursue a PhD in applied field. But this is the opposite scenario in US. If you do belong to the theoretical background, it is very unlikely that you will get the funding, because they think about the current scenario, that how like life of people can be impacted from the science and technology. So that's why if you want to pursue the work in applied field, you can choose USA, and if you specifically belong to optics and photonics, you can go to Germany also. Germany is very well known for the applications, and also Israel, you can go there. Okay,
So I think that addresses his question. And one more question from Devasrita, which asks, which is the best institutions for spectroscopy students for PhD program?
Okay, so yeah, as I have told that there are like so many people in IISER Bhopal. So obviously IISER Bhopal, we have like 7-8 faculties who is doing work in spectroscopy, from going to nonlinear spectroscopy to transient absorption to Raman spectroscopy and all. So obviously you can you can like take IISER Bhopal in your selection. And also IIT Delhi is very much well known for the applications in optics. IISc Bangalore has few faculties, even like very good faculties are there. So I can tell you about one name. So he's a Bengali. Actually, like I have like forgot his name. So if you just follow the current news, okay, yeah, that's
We can just
Arindam
skip the
Bhattacharya or
name.
something.
Okay, okay, fine, that's fine.
Yeah.
Because it's
So
being recorded and we are going to place it in the YouTube. So
right. So they actually have developed something known as like they were like claiming about something of AUAG core shell they have prepared, which can lead to the like high temperature superconductor. So he is a very good person, and he got the Shanti Bhatnagar. So this kind of faculties are, I think, everywhere in different organization. You need to find them, but particularly saying, I think IIT Delhi and IISER Bhopal has huge number of professors who is working in this field, specifically IISER Bhopal and IIT Delhi. That I can say.
okay, thanks. I think this addresses our question as well. And thanks again, sir, for joining us. I don't know what to say this evening or this morning. As far as this morning,
Yeah,
everything is
it's
good.
for my morning. In case of you
Yeah,
guys, it's kind of going to night. So yeah, and
yeah, we
thank you
are.
for amending the schedule according to like my time. So yeah, thank you for that.
Yeah, thanks a lot, sir, again. And now we have to wrap up this session. For that, I would like to request Mr. Kuntal Ghosh, who is the founder member, one of the founder members of Masterclass PHU, to formally convey the vote of thanks to the listeners and who has joined this session. Mr. Ghosh, are you there? Okay, I think some network problem is prevailing with him till now. So in that case, on
Okay,
behalf
I
of
just yeah, can I just say
yes, yes, sir.
one thing? So yeah,
Yes,
actually, like I told the professor name correctly, but the surname wrong. So it's Arindam Ghosh. Okay, so I just want
okay.
to like make it correct. So this is Arindam Ghosh from IISc Bangalore.
Okay, we got it. So I think Mr. Ghosh has managed to join this meeting again. Mr. Ghosh, are you there? Then I would like to request you to convey the vote of thanks.
Hello.
Yes, you are audible, Mr. Ghosh.
Okay. Thank you, Dipankar, for lovely talk. And thank you, all of you. This is a very long session so far. So thank you. You can leave and thank you, all of you.